Good morning, and today we're going to talk about lesson 8 and 1, lesson 3 and 4, the power of power rules and the exponent rule of 0. So 0 exponents, so x to the 0 power. So let's look at what we are going to learn today. Let's go to our magic tablet and start to learn the two key things today. And that, again, is the power of power rule. And then we're going to learn the 0 exponent rule. The 0 exponent rule. Okay, so let's start off with the power of power rules. Now, remember that we learned already about how we deal with the product of two powers, right? The two product, if I'm multiplying two powers together with the same base, I simply add the exponents. Okay, this was the product rule. Okay, now we're going to learn the power of power rules, and that says, that looks a little different. So that would be like x squared, x raised to the second power, all raised to the third power. So the way that we make sense of this is we're just going to do the same thing we did above. We're going to say we don't really understand what this means, so we're going to expand it. So we're going to expand this guy, and we're going to say, well, we know what these symbols mean to tell us what they tell us to do. So x squared is the same thing as x times x. That's by our definition of a power, right? So we've taken x squared and we've split it out into x times x. Now, similarly, because we have another exponent, we have to do the same thing one more time. So if we have x times x to the third power, we have x times x times x times x. We do it 3 times because that's what the power, the definition of a power, tells us to do. So we've expanded x times x, and then we're going to expand x. I think we've expanded that twice, and then we're going to expand this 3 times because that's what it tells us to do. So now we have our answer, which is x times x 6 times, right? So we get x to the 6th power. All right. So what you can see, if we do this a couple times, we could also do the same thing with, say, x. We'll keep it kind of small so that we don't have to write this out too many times. Well, let's put it down here. Let's put it in a different color so we don't walk across each other, and we'll say x to the 4th to the 3rd power. And so this would be, x times x times x times x all to the 3rd power. And if you can see, if we write this out 3 times, x times x times x, we expand again because we need to take care of this exponent. We've already taken care of this exponent. We take care of this one, and then if we write this out 3 times, there's our first time, there's our second time, and then we write it out a 3rd time. We get 1, 2, 3, 4, 5, 6, 7, 8, 9. We get 3 sets of 4 of these, or 4, 3 sets of 4 multiplication, or we get x to the 12th. So you can see that here we get, 3 sets of 2, 3 sets of 2, 3 sets of 2, and here we get 4 sets of 3. And what is that? That's just multiplication. So our rule, our power of power rules, our power of power rule says that x to the m all to the n is equal to the x time to the m times n power. So we're going to put a big star here. You know what star means, and that's our power of power rules. So make sure that you understand this and see how this is multiplication, but you should know why the product rule then becomes the addition. So make sure that you know how to prove this guy and this guy, why this becomes multiplication, but this becomes addition. Now we can expand our power of power rules, and it doesn't expanding the power of power rules. And let's look at that. So we're going to write something just a little bit more tricky, and we'll say x squared y, which is y to the first, all cubed. And we're just sticking with low exponents so that we can write this thing out. And we'll do the same thing here that we did down here. So we're just going to expand this out, and we're going to say, well, that's x times y times x times y times x times y. And if now we know that this is all associative and commutative because everything's just multiplied together. So if we add things in any order, we multiply things in any order, we can just rewrite the whole thing. So let's put our 6 x's at the front. Right, here's our 6 x's. And then we're going to put our 3 y's at the back. Here are our y's. And so our answer becomes x to the 6th times y cubed. And notice what we've done. We've done 3 times 2, and there's our 6. And then here's our imaginary, or our 1, our implied 1. We won't call it imaginary, it's implied. And our 3 times 1 becomes 3. So it doesn't matter. So in our product rule, if we look all the way back down at our product rule down here, it says that x to the m n is equal to x to the m times n, but that applies also if we say x to the m y to the n all to the x power. We can say that this extends infinitely, and so we could say x to the, well, no, let's not make this an x. Let's get rid of that. Let's get rid of that because we've already used x. So let's call that we're going to call this a q. So this will be x to the m times q times y to the n times q. And this is just an extension of the power rule that can be taught. And you can draw other examples of this, and I'll leave it to you to figure out, solve this problem here, where we're going to go, x squared y cubed z to the 4th, all raised to the 5th power. This will extend further, and we can do our multiplication like this. And I'll just write it down for you, but I'll leave it to you to show why this is true. Good. Okay, and let's do one more before we go to the 0 exponent rule. And that would be this. So if we have 3x squared to the 4th, this becomes 3 times x times x times 3 times x times x times 3 times x times x times 3 times x if we expand it. And so if we rewrite the whole thing, we get 3 times 3 times 3 times 3 because we can commute our 3's, and then we get times x. And I'm not going to bother doing this for you again. So we got 8 x's. So that's 3x to the 8, sorry, x to the 8th. And so what is 3 times 3 times 3 times 3 is 3 to the 4th times x to the 8th. So our numbers, so the point here is that these numbers inside here work just like variables. And we can multiply down to get our answer. So this would be 4 times 1 is our 4, and our 4 times 2 is our 8. And again, don't think about the rule without thinking about the y. If I multiply, because remember, here are my 4 3's. And I got there by expansion. And you will need to, I'm just going to write this down. Know for quiz and test how to show all rules, all exponent rules by expansion. Exclamation point, exclamation point. Oh, that looks kind of like a person. Let's see. Some wrinkles on the foreheads. See, oh, nice. Smile. This looks kind of like a Martian or something. All right. Very good. So, and similarly, if you have, let's see, if you had, say, 2 squared, I'm just going to give you another one here. 2 squared x to the 4th, all to the 9th. This is going, I'm just going to tell you the answer. But that's going to be 2 to the 18th, x to the 36th. All right, now we're going to finish off with the 0 exponent rule. And so you're going to look at this and you're going to say, well, 2 to the 0, you're going to say, some people will look at that and say, oh, well, anything 0, that's a 0. Well, no, that's not the right answer. 2 to the 0 is equal to 1. And I'm going to show you why. So let's look at this. So we're going to use a rule that we know called the quotient rule to kind of show this. Quotient rule to prove the 0 exponent rule. Use. Okay, so let's do that now. So I'm going to show you something tricky. There's nothing up my sleeve here, but we're going to show we're going to just start with this idea of 2 cubed over 2 cubed. 2 to the 3rd power over 2 to the 3rd power. Now let's expand. So this is a valid expression. Let's look and see what it's equal to. Well, in one sense, it's equal to, using the quotient rule. If we use this quotient rule, we can say, well, this is equal to 2 to the 3 minus 3 power, which is equal to 2 to the 0. So we know that 2 to the 3 divided by 2 to the 3 is 2 to the 0. Now let's look at it another way. 2 to the 3 over 2 to the 3 is equal to 2 times 2, 2 times 2, all of that over 2 times 2 times 2. And this is, I'm just using, here I used the 0 quotient rule to get from here to here, from here to here. And to get from here to here, I use the definition of powers. Well, 2 times 2 times 2 times 2 is 8 over 8, and that equals 1. Well, let's look. If, if 2 over 3, if this all equals 2 to the 0, and at the same time it equals 1, then 2 to the 0 must equal 1. And that's our 0 exponent rule. It basically says, let's go all the way back up to the top, and it basically says anything to the 0 power is equal to 1. And there's actually a caveat on that. That it is that providing x does not equal 0, because it turns out that 0 to the 0 is what they call undefined. So 0 to the 0 is not equal to 1, but anything else to the 0 power is equal to 1. So let me show you just really quickly a few trick questions that you may see someday, which would be like 1, 2, 3, 4, 5 to the 6th over 3, 4, 9 to the 2nd, all to the 0 power. Well, don't even figure out, it doesn't even matter what this is. That equals 1, because anything to the 0 power equals 1 except 0. Let's do one more example, and that looks like this. It would be like x squared over y cubed z to the 9th, 42 of that, and then 1 plus that, all to the 0 power times x squared. Well, we'll know that this whole thing here equals 1 times x squared. So your answer is x squared. Okay. All right. Good luck on your homework, and we'll see you next time. Have a great weekend.